Good afternoon, everybody. I'm Bart from biplanehangar.com. This is my Pitts Model 12. I've had it for about a year and a half. I bought it back around May of 2024, and today is the day before Thanksgiving, November 2025. First flew it myself in May of 25, so I had it for about a year before I was able to fly it for the first time. As it stands, it has about 30 hours of flight time and about 43 hours of runtime on the engine. So the tail number is 812 Mike Sierra. And the engine was originally built by Barrett. It has their second generation high compression pistons. It has Barrett's fuel injection system, Barrett's electronic ignition system, as well as their automotive spark plug conversion. And the purpose of the video today is to discuss the project that I am starting on the airplane, removing the original fuel system and swapping it out for a new one that we will discuss. So thanks for joining. If you have any questions, come by the website, biplanehangar.com. Feel free to post in the build thread and we'll discuss any questions you have. Thank you. So these are the components from the original fuel system. Fuel could be fed to the engine either from the wing tank or from the main tank, and that was done through this brass three-way valve. From the valve, fuel went into an electric boost pump, then into a gascolator, and this gascolator also has a screen in it, so it does serve a purpose as a filter, slightly. Fuel would go through the firewall and then into this mechanical fuel pump. From the mechanical fuel pump, it would go into this device, which is referred to as a debubbler. Apparently, fuel can get hot at different points in the fuel system. Fuel vapors can develop, and what this does is it captures them, allows them to go out the top, back to the gascolator or to the main tank, where the fuel would cool, recondense back into liquid, and go back into the fuel system. But from the debubbler, it would go to this fuel injection system. It's basically a throttle body or a single point fuel injection system. Fuel would come in this port here. It would be metered by the throttle body, sensing the airflow coming into the engine. Metered fuel would come from this port through this hose up into this block, where it would then come out of this nozzle, kind of like a shower head effect, get sprayed into the airflow, and then get drawn into the engine. So this is how the existing fuel system was built with these components. And next, I'll discuss the issues I have with it and the solutions that I've been considering, and ultimately the plan that I'm going to be building out on the airplane. So as I said earlier, the first flight for me with the airplane was May of 2025, and I've put about 17 hours on it since the day this video is being made. It hasn't flown actually in about almost 3 months, I think, 2.5 months, because of the problems that I've been having with the fuel system. So in the 17 hours I've flown it, I had a problem initially where fuel was leaking out of the intake, and the problem, I didn't know what the problem was. I reached out to Barrett. I sent them the whole throttle body, the whole fuel injection assembly. I sent it back to them, and what they did was they took it apart up here. There's a little poppet valve, it's called, and I believe they said they replaced the O-rings, cleaned out the poppet valve, put it back together again, bench tested it, it wasn't leaking. So they sent it back to me, and I put it back in the airplane. I flew the airplane for about 5 or 6 hours, took it to a contest. It developed the same leak just before the contest flights were to begin. So it was leaking again, and it wouldn't idle. I tried multiple times to get the problem to fix itself, unsuccessfully. So left the airplane at the airport, and spoke to Don Rivera, who owns Airflow Performance, which is the company that makes the throttle body. Spoke to Don, ordered a new poppet valve, went down, put it in. That fixed the leak, it restored the idle, and I was able to fly the airplane home. So a couple weeks later, I went out to fly again, and the electric fuel pump had failed. It was only making about 8 psi. So I've had multiple problems with the fuel system, and you're probably saying, well, you know, that poppet valve leaking isn't Barrett's fault. The electric pump isn't Barrett's fault. You know, it's a Barrett engine, so I'm not saying it's their fault, but the point isn't that I had these problems. The point is that because of the problems, I found out about other issues with the fuel delivery for the airplane. So my mechanical pump, at best, I saw about 39 psi on the fuel gauge. The design fuel pressure for the airplane or for the engine is, or for this throttle body system, is about 45 psi. So in talking to Airflow Performance about the issues that I was having with the leak, I found out other things about the fuel system that I wasn't aware of previously. So the engine needs 45 psi minimum so that you have proper mixture control all the way up to the top of the RPM band. At 39 psi, what was happening was I'd be bringing the throttle up for takeoff, and as I got up to the higher RPM settings, because it didn't have sufficient pressure to deliver the full rich flow at max throttle, the engine would taper off and go lean a little bit as I was approaching full. So that was one issue. Also, this mechanical pump, I learned this over the course of dealing with these other problems. This mechanical pump is originally designed and built for the engine when it had a carburetor. So the carburetor, that fuel system, required about 5 psi. The throttle body requires 45 psi. And the most I ever saw from this was 39 psi. So this was running at 8 times its design pressure, trying to make sufficient pressure for the fuel injection system, which it wasn't able to do. But in the process of making all that pressure above its original design pressure, it's my belief that it was causing damage to the fuel pump. So this pump has about 43 hours of runtime, and you can see that this sharp seat that the pressure regulator for the pump, so this little valve rides in this fitting. The face of this valve sits on this sharp edge, and what happens is this spring, which is a stiffer spring which was put in this pump from the original in order to make more pressure, that spring is pushing that little valve face against that sharp edge, and it's wearing a groove into it, and it's also scuffing the shaft of that valve. So this damage that I found in mine after 43 hours, I don't know how well you can see that, but that's consistent with damage that an airplane had that actually crashed because it lost power. So I don't have a lot of faith in this fuel pump. I don't believe there's any safety factor operating the airplane with this pump. And you also have the added risk that if this pump fails, or when it fails, as this wear increases and as it continues to shed metal, it's going to clog the inlet screen for the throttle body. So there's a finger strainer in here, relatively fine one, and the accident airplane had metal filings in that screen. I took that apart on another airplane and found metal in it that was consistent. It had a similar radius. It was a sliver of metal, looked like it was shaved off the face of this valve. Other operators, I've seen photos of this screen loaded with metal. Another owner took it apart, also found metal in that screen. So it seems to be a failure mode of this pump, that it sheds metal, clogs this screen, and causes the engine to lose power. At least that's the impression that I've gotten from the multiple people I've spoken to. So the two solutions that I've been able to come up with through discussions with other owners, one possibility would be to put an outlet filter on this pump so that if it does start to make metal, if you want to run the mechanical pump with the electric boost pump, but if this mechanical pump does start making metal, put a filter element just downstream of it to catch metal coming out of the pump, and then have the electric pump in parallel now, so it comes in just downstream of the filter, and you can almost completely eliminate the risk of a failing mechanical pump clogging the inlet of the throttle body and keeping you from being able to get fuel to the engine. So a filter downstream of the mechanical pump, the electric pump comes in downstream of that filter, and both pumps have the ability to put fuel pressure, full fuel pressure into the throttle body and run the engine. So that's one possible solution. Again, the throttle body needs 45 PSI minimum to run full flow at all RPMs, all power settings. I haven't seen it from this pump, so I'm not really interested in continuing to use these components for the fuel system. So what I'm going to be doing is removing all of these things from the airplane, and I am going to be installing a new fuel valve, and this is only a 2-port valve, so I'm going to be running my airplane similar to the way the Pitts S2 runs, with a wing tank that just refills fuel into the main tank. So I'm only going to feed the engine from the main tank. The fuel is going to be delivered via 2 electric fuel pumps, and these are also from Airflow Performance. These are going to run as much as 80 gallons an hour at 45 PSI all the time. So there's never going to be another issue with whether or not the throttle body's getting sufficient fuel pressure to drive the nozzle and keep the mixture exactly where I want it, regardless of the power setting. Being that these are both electric pumps, there's an issue of them getting warm when you're running at low power settings, when you're not using a lot of fuel, but they're still making full pressure. So the way to resolve that is to keep the pumps from getting hot by returning fuel from the throttle body. The throttle body happens to have a return fuel line right here. So we just take this plug out, we put a fuel line to it, and we're going to return fuel into the header tank actually. So there's always going to be a circulation of fuel. That also eliminates the need for the debubbler, because in constantly circulating the fuel, you're also constantly purging air from the fuel system. So that's kind of a double bonus. We're getting rid of the gascolator and just putting in a dedicated finer mesh filter, and that's going to be on the suction between the tank and the fuel valve. And then we're also putting in a pressure regulator, which is going to be forward of the firewall prior to fuel entering the throttle body inlet. So another small change we're going to make is this little package is going to be mounted somewhere in the vicinity of the main tank, and this is just going to make sure we have a positive transfer of fuel from the wing tank to the main tank. So there's a small pump, a little pressure switch that's going to light up a light when the pump's making pressure, and an on-off valve, positive control on-off valve. So when we throw the switch for fuel transfer, it opens the valve, it activates the circuit for an indicator light, and it activates the pump. When the pump runs out of fuel to pump, the light goes out, and we just flip the switch and it closes the valve and shuts off the wing tank again. So that's going to be for fuel transfer. And then the last little change we're going to make, instead of having the red cube for fuel flow mounted to the engine mount between the engine and the firewall, it's actually going to be put into this line right here, probably mounted somewhere in space right about here, so that fuel comes out, goes through the red cube for fuel flow measurement, and then into the block where it's sprayed into the engine. So this line is metered fuel. That's actually fuel that we're using. The other lines are going to be circulating constantly. So to do it with one fuel flow meter, the recommendation from Don at Airflow is to put the sensor in this line. So those are the big changes. Another change, which is going to make this safe, is the addition of a second battery. So I have 2 EarthX ETX 680C. These are experimental non-TSO batteries. There's going to be 2. One is going to run the airplane. The other one is going to be dedicated to the second pump, so that if there is a problem with the airplane unrelated to fuel where I have to shut the master switch off, there's going to be a second dedicated battery powering the second pump via a switch and a circuit breaker. and that'll keep the airplane flying. It'll give me a minimum of 45 minutes of runtime. The way the batteries are going to be set up, the second battery is going to charge off the electrical system, but it's not going to contribute at all to the main electrical system. But this first battery will be able to contribute to the second battery's job of running the pump. So maybe that's a little confusing, but we'll talk about it in the thread. So there's going to be a second source of electrical power, actually a third source. You'll have the alternator, the first battery, and then the second battery. So 3 sources of electrical power. At all times, you'll have 1 battery fully charged in reserve, waiting to do nothing but power the second pump. So that's going to get us to a runway. It's going to get us to a highway, a nice smooth field, whatever it is that we need, should there be an emergency with the airplane. So there is redundancy built into this, and these pumps are constant use. You can run them at their rated pressure at 12 volts continuously, and they don't heat up. There's no duty limit on the length of time that you can run the pumps. So this is a full 45 PSI, 100% of the time, to the throttle body with electrical backup, and we're going to be feeding the main tank from the wing tank. The reason the fuel delivery is being changed, why we're not going to be feeding the engine from the wing tank, is because if we were doing that, we would have to have a return to both the main tank and a return to the wing tank, and we would need a duplex valve. So this valve, instead of going from a 3-port to a 2-port, it would go from a 3-port to a 2-bank 4-port or something like that. But we would need a duplex valve that could have both inlets and returns for both fuel tanks, which starts to get a little crazy with the amount of space that we have with all of that plumbing. So we're just going to simplify things, run the engine from the main tank, and if we want to go somewhere and we want to use that extra 16 gallons from the wing, we're just going to have a transfer system to put it into the main tank where the engine can pull it. All right, if you have any questions, feel free to come by the website. It's biplanehangar.com. There'll be a thread there dedicated just to this project. Happy to answer questions. If you see something you think that could be done better, I'm happy to consider your suggestions to discuss it. And thanks for watching. Appreciate it.